Welcome back to our channel. My name is Teacher Smith, and today we are going to understand a very interesting topic. Now, to understand this, I have taken a question from the past year GEP. So, let's just have a look. Here, the question says, there are 10 more girls than boys. Each girl has 2 red balls. Each boy has 3 blue balls. The number of blue balls is the same as the number of red balls. How many boys are there? So let's try to understand the question first. Here, there are 10 more girls than boys which is given to us. So let's say this is the number of girls that are present and this is the number of boys. The question says there are 10 more girls. So here, the extra girls that you can see is nothing but total of 10 girls. Then the question says each girl has 2 red balls. So for every of the girl that is present, everyone has 2 red balls. Now regarding the boys, then all the boys have 3 blue balls. So here everyone has just 3. And we don't know what is the number of girls and what is the number of boys. The question is asking us, if the number of blue balls and the number of red balls are the same, we need to find just the number of boys that are present. So let's see how we can solve this question, because here what the problem is, here there are 10 girls that are present. This number I know, but regarding the numbers that are present here, we don't know the number. So let's see this, how we can solve using an example. So let's say there are 15 apples, okay? Now this 15 apples I have to distribute to 3 Marios. So how many apples will each Mario will get? Yes, here everyone will get 5 apples, making sure we distribute equally, okay? Now let's say if I give everyone, because since now what I found out is each of the Mario were mischievous. They didn't do the homework. So I tried giving them less apples. Now everyone has 3. Now if I distribute everyone with 3, how many apples will be left? Yes, there will be 6 left apples. Now since there is a left part, since there is more part, there's 6 more apples left. So what I can understand, this is nothing but called as excess situation, where there are excess number of apples still with me. Now let's say if next time they try to do their homework well, so I will praise them. I will give them rewards. Now this time I'll give them more apples. So now everyone has 6 apples. But is it enough? Of course not. If I try giving everyone 6, then what will happen? This total is 18, but I only have 15 apples. This means there are 3 more apples needed. Now this situation where there is need, where we need more, so we call this situation as shortage. So there's 2 situations. One is excess, when there is more left with me, and there is shortage where I need more to distribute them. Now let's see how we can tackle questions based on this. For this, let's take another example. Let's say I have some number of carrots that are present, and I want to distribute this carrots to some bunnies. So for the bunnies that are present, I don't know the number of bunnies that are present. But let's see if I try distributing the carrots to them. Let's say if I distribute 5 carrots to each one of them, and then the number of carrots that are left with me is 12. Now in another situation, let's say if I distribute each of the bunnies with 7 of the carrots. Now the question arises how we can find out the number of bunnies that are present. Now in order to find out the number of bunnies, what we have to think is, see, there are 12 left. What if there's no 12 left that is present? What if this part was not present? Then I would have distributed this 12 to each one of them, right? Now since everyone already has 5 and this 12 I have to distribute equally, making sure everyone has 7. This means for every of the bunny, how much more do I have to give them? Yes, we can calculate it. 7 minus 5, which is 2. This means for each bunny I have to give 2. But now total I have 12. How I can distribute this 12? Everyone gets 2. So how many bunnies I can give this to? Yes, if everyone I try to give 12, then in order to find out the number, it's nothing but 12 divided by 2, since everyone gets 2, which is nothing but 6. This means the total number of bunnies that are present here is 6. So which thinking process that I use? Here, see, there's just 12 left. Now what did I do with this 12 left? What if I imagine I distributed this 12 already to them? Now to distribute, I need to check what is the difference between each of their single value. We found out the difference that is present is just 2. This means this 12, everyone I have to give just 2. So what we can understand, whenever we have a question based on excess, we can imagine that the excess part I have already distributed to them. Now let's take another example. Let's say there are some number of cheese cubes that are present. I don't know what is the number, but let's imagine. Now this cheese cube I have to distribute to some Jerry's. Now Jerry's really like cheese cubes, right? But the problem is I don't know how many Jerry's are present. But let's say if I try to distribute everyone with just 4. Now when I started distributing 4, I realized that there are 14 left cheese cubes with me. Now let's say instead of this situation, if I try distributing more cheese cubes to them, let's say now it's 7. Now let's just think. If I start distributing with them with the 7, now the problem is there are 4 more needed in this case. There are 4 more cheese cubes needed. This means it's not sufficient for them. There's a shortage of cheese cubes. So how to solve this question now? Now, as I just thought, in the previous example, we assumed that there is no extra part. We just distributed the extra part with everyone. Now here, what is the extra part that is present? We know the extra number of cheese cubes at the first situation was just 14. But in the next situation, it's 4 needed. This means if I try distributing them 7, everyone gets 7. This means the 4 needed part is also removed and this 14 needed is also with me. So what is the total number of cheese cubes I have now? Yes, the total number is just 14 plus 4, which is nothing but 18. Now this 18 cheese cubes I want to distribute. But from 4 to 7, what is the change that I can observe? This means each of them will receive 3 more. Now I have in total 18 cheese cubes and everyone I have to give 3. 3 and 3. So how many Jerry's I can distribute it to? Yes, first we can find out that 14 plus 4 is nothing but 18. And this 18, since everyone, each one gets 3, so it's 18 divided by 3, which is nothing but 6. This means there are 6 Jerry's which are required to satisfy this 2 conditions. So what we can understand from this question, this example, let's just pay attention. Here, the extra part that was present here, I try to assume that we distributed this with each one of them, making sure there is no left out part and no needed part. So whenever there is this situation, I can find out the total number of the change that is present on the right hand side. So whenever you have question based on excess and shortage, you can find out what is the total change. Here it was 14 plus 4, which is nothing but 18. And then how did we get this 3? This 3 is nothing but the difference that is present between 4 to 7. But this difference is just the single value difference. So I can find out the single value difference. And what do I have to do with this total? We have to just divide it. So divide it with the single value difference. And then what we can get? The 6. What does the 6 represents? It represents the number of Jerry's. So here in this example, it represents just the number. So whenever you have question based on excess, we can find out what is the total that is present. But whenever we have question based on excess and shortage, we can find out the total change. That is excess, shortage, just add them together. Now understanding this, let's move on to our question. Now our question also has some extra part. The extra part, that is nothing but 10 girls. But these 10 girls have 2 red balls. So this total number of balls that are left with me is how much? Yes, it's nothing but 10 times 2, which is nothing but 20 balls. Now this 20 balls, the question says the blue balls is equal to red balls. So let's say if this 20 balls, I have to distribute. This means there's equal number of girls and the boys. Now, if there's equal number of girls and boys, what we can first find out is the total change. That is the number of balls left to distribute, which is nothing but 2 times 10, which is 20. Now, let's say if there is no extra part, let's say if I remove this part here, this means this 20 balls will be distributed to each of the boys that are present. But for boys, how much do each boy need? Yes, we can find out the difference from 2 to 3. What is the single change? Yes, the change is just 1. So this means here, everyone gets 1 more, but I have 20. And if I give 1 to each one of them, what is the number? Yes, the number is just 20. That is 20 divided by 1, which is 20. So, the number of boys that are present, if everyone gets plus 1, then the total number of boys is 20 divided by 1, which is nothing but 20. So, the number of boys that are present in this situation is 20. So, what we can understand from this is 2 things. First, we have to find out what is the total leftover part. Even if it's excess, even if it's shortage, just add them together. Then we can find out what is the single value change for each one of them from the before to the after. Then by just dividing it, we can get the number here. So let's try to summarize this. Whenever we have question based on excess and shortage, the first thing, let's just assume that there is no extra part. This means this extra part I have to distribute it to everyone. Just like a simple example. So what we can do is we can convert our information which is unknown to known information. Then the next thing, what about the formula? For the formula, we should know the total change and the single difference. If I know these 2 things, just by dividing, I can get the number. Now, if you have understood the question well, you can try the practice which is given over here. You can try this practice, you can pause the video, try this practice, and then you can mention your answer in the comment box. For now, it's me, Teacher Smith, signing off right now. But if you have any problem related to this question or any other question, you can scan this QR code. This is our P2, P3 study group. Any problems, just message me. I'll help you to solve the math down. So, I'll take a leave from here now. I'll see you in the next video.